given in your homework. And the way we use this chart, we take the sample size, lowercase n, and we find the corresponding critical value. This is the value to beat. If the absolute value of our correlation coefficient is greater than that critical value, then we say, yes, a linear relationship exists. We take the absolute value, R, we match up the sample size. If the absolute value of R is bigger than the critical value, then yes, a linear relationship exists. So let's see an example using our data from number 26. Where you got your calculator. So where do we go in our calculator first to put our data in? That, excellent. And then after that, wonderful. L1 is our first variable, which will be credit score. And L2 will be our second variable, which is interest rate. Our interest rate depends on our credit score. Our credit score predicts our interest rate. If you have data you want to move your cursor all the way up to the top, press clear, and then enter. Same thing, you want to remove data, move your cursor all the way up to the top, press clear, and then press enter. Now we can enter our values. Everybody has to know how to use the calculator. You have to know how to use the calculator. Everything else is optional, but you have to know how to use the calculator. Always make sure to go back and check your data. One wrong number will throw everything off. All right, so the first thing we're going to do with our data, and this is comparing FICO credit scores with corresponding interest rates on 36-month auto loans. So we're going to do a scatter diagram, a scatter plot, and that's going to be listed with our plots. And where do we go for our plots?
Stat plot.
There you go, stat plot. Stat plot is right above y equals, so how do we get above a button? Excellent. And we want to make sure to turn our plot on, so we're going to press enter. We have to have a black box around the option that's turned on. So make sure your cursor is on, you press enter, and your black box is there. Our scatter plot is the first option available right beside type. And then our X list should be the name of the list where we have the explanatory variable. Y list should be the name of the list that has our response variable. The mark is just what you're going to see once we produce this graph. And once we're ready to graph, we need the calculator to format the window for us. So where do we go to make that happen?
Zoom.
Excellent. Zoom, and then excellent. Zoom 9, which is Zoom stat.
Nice.
So there is our scatter plot, our scatter diagram. We we already answered question A. Which variable do you believe is likely the explanatory variable? Independent variable, the variable you start with, your cause, this is your credit score. And our response variable, our result, our dependent variable. What happens at the end is that our interest rate is set. C, we want to determine our linear correlation coefficient between our FICO score and the interest rate on a 36-month loan. So before we can do that, we need to make sure your diagnostic is on. Once you turn it on, you never have to turn it off, unless, well, you never have to do it again, unless you change the batteries in your calculator. That's the only time it gets reset. So what we need to do is go to catalog, and the way we get to catalog is right above 0. So how do we get to anything that's above 0? There you go. And you can scroll down to diagnostic on, or you can just press the letter D, which is right above your inverse button. And you know you can do that because in the top right corner you see that A. That means it's in alpha mode. So you scroll down to diagnostic on, or click on the inverse button. That's a little shortcut. And we're going to have to press enter twice. Press enter one time to select diagnostic on. Press enter again to make the calculator actually do it. So you should see diagnostic on and done. That's how you know you have run the tool, and now you're good to go. So now where we're going to go is stat. And then after stat, we're going to calculate. We used option number 1 previously when we wanted our 5-number summary, when we wanted our mean and our standard deviations. Now what we want is option number 4, LinReg. That's our linear regression. Stat, calculate, option number 4, linear regression. If you have the old operating system, this is what your screen looks like. The calculator assumes your data is in L1 and L2, so you can just press enter. Your new operating system, this is what your calculator looks like. Wherever you put the X value, make sure that's under X list. Wherever you put the Y value, make sure that's under Y list. Leave frequency list blank, leave store regression equation blank, and come down to calculate. And this is what you should have. If you are missing R squared and R, it's because you did not turn on your diagnostics tool. Yes. So, lots of good stuff on this screen that we're going to need. First thing we need is that value of R, which is our linear correlation coefficient, negative 0.976. So, this tells us our strength, and it gives us our direction. We can see the direction from our scatter diagram, and also from the sign of our R value. So what's our direction? There you go. And our strength, if it's close to -1 or +1, is strong. If it's close to 0, it's weak. So our value should have a strength of
weak.
Strong meaning is very close to a line. Weak meaning is not very close to a line. Does a linear relation exist between our FICO score and interest rate? So we look at our sample size. We have 1, 2, 3, 4, 5, 6 values. We go to our critical values table. We look at the 6th row. And our value to beat is 0.811. So we take the absolute value of the correlation coefficient. If the absolute value is greater than our critical value, then we can say yes, a linear relationship exists. So absolute value of our R is greater than the critical value for 188. So yes, a linear relationship exists.
If the strength is strong, doesn't it just typically mean the answer is yes?
That's a good question. Yes and no. Now, why do I say that? If you had a lower amount of points, like 4, then the R value to beat is 0.95. So you can get like 0.94, which would be strong, but it doesn't meet that value. But any other sample size is bigger than that. That's an excellent question. All right, so that is 4-1. Scatter plots, we never connect the points. R values should be between -1 and +1. It gives us the strength and the direction of our linear relationship and identifying whether we have a linear relationship or not. And for 2, we talk about our least squares regression line. So we have a bunch of points, we plotted them. We're trying to find what's the best equation that's going to fit these points. That is our least squares regression line. What's the best line that's going to fit these points? So y hat is another symbol we're going to add to our long list. Capital N, lowercase n, r, s, s squared, sigma, sigma squared, capital sigma. Yeah, add on y hat. That is our prediction equation. And v sub 1 is our slope in college algebra. We use m for slope. V sub 0 is our y-intercept. In college algebra, we use b. So, same exact concept, slope and y-intercept. Same exact concept for college algebra. How do we interpret the slope? How do we tell what the slope means? Every time the x variable goes up by 1, the y value increases or decreases. This depends on whether your slope is positive or negative by the absolute value of the slope on average. You have to say on average because this is an average overall. So every time the x value increases by 1, the y value will increase or decrease. Increase if your slope is positive, decrease if your slope is negative by absolute value of the slope. Just like with z-scores, if we're telling what it means and we use decrease, we do not use another negative. Decrease implies that that value is negative. If we're interpreting the y-intercept, in college algebra, we found y-intercepts by making x equal to 0. So we have to consider 2 things. Is 0 reasonable for x? And do any of our observations near x equals 0 exist? If you answer no to either question, there is no interpretation. Is 0 reasonable? Could x ever be 0? And does 0 even come close to any of your x values? If you answer no to either one, there is no interpretation for y-intercept. If you do have an interpretation, the y-intercept is the value of the response variable when the explanatory variable is 0. So the y is the value when x is 0. So, looking at our example, our least squares regression line, the best line we can get through these points, negative 0.076x plus 61.369. That's our least squares regression line, our best fit line, the best linear equation we can come up with to fit those points. Is it gonna fit exactly? No. How do we know that? Because our R value is not -1 exactly, but it's close, so it's a pretty good predictor. Identify our slope. Our slope is whatever that coefficient of x is. And we want to interpret it. So if the credit score, that's our x value, our explanatory value, if our credit score increases by 1, then our y variable, in this case is the interest rate, decreases because our slope is negative by 0.076. Make sure you include on average there. Everybody with me? Questions? Any questions? Everybody sign in? Identify the y-intercept. Our y-intercept is 61.369. And interpret it. To interpret our y-intercept, we have to think of two things. Is 0 possible? Credit scores are from 300 to 850. So is 0 possible? No. So automatically, there is no interpretation. Is 0 anywhere close to a credit score that we have in our data set? No. No to either one of those two questions means there is no interpretation. Predict the interest rate a person would have with a credit score of 600. So looking at our data set, 600 is possible. It's in that midst, so we can use it. To predict this, we take our equation, and x, our credit score, is now 600. And we just plug that value in. I'm telling you. 15.769. That is our prediction. With a credit score of 600, we will predict that your interest rate will be ridiculously high, 15.769. Questions on 4.2, least squares regression, getting your best fit line, finding your slope, finding your y-intercept, and interpreting both of those values. Yes.
Okay, so I'm not gonna lie, I'm completely confused.
Okay.
I don't understand, I mean, I don't understand any of it, but I really don't understand the D. I don't know where you got the .811.
Gotcha. So, on the slide right above it, we got a chart from table 2. This chart lets you know when you can say a linear relationship exists. So in our chart, we had 6 data values. So we had 6 different people that we interviewed. And then the critical value is .811. So that's our score we had to beat. So we had to find our R value and take the absolute value of it, because the chart only has positive numbers in it. So since our R value, the absolute value of it, is bigger than that 0.811, then we can say, yes, it's linear. Excellent question. Give me another.
Where'd you get the negative 0.076 in the y-hat formula? And then 6136?
Excellent. So we went to stat, calculate, and linear regression. And then those were the values the calculator gave us for our slope and our y-intercept.
So basically, A just takes the place of where M used to be.
Absolutely
Okay.
right. So in college algebra, all we did was we had 2 points, and we did y sub 2 minus y sub 1 all over x sub 2 minus x sub 1 to get our slope. Now we have more than 2 points. So the process for getting our slope is a little more complicated. But this is the same exact thing as y2 minus y1 all over x sub 2 minus x sub 1 on steroids. Yes.
So, sorry.
It's
my
okay.
A-
Please, the other people have these questions, but they text in and on the website and all this other stuff, so they're not trying to really figure it out. But thank you for asking.
My A is negative 76.36. It's not.
Excellent. So I would say that when you put in your data, you probably missed the decimal places.
That's
Stat and then edit. See, wonderful questions. And tell me your name. I'm learning a few at a time. Kelsey? That's one of my friend's sisters' names. Other questions? Who else is brave?
Is there another way to determine large black?
Yes. And when you read the textbook, they showed you. But for us, technology, plug numbers in, let's do it for you. What's your name?
Mahan. It's actually, my name is actually one of the most popular names
In England or India?
in England.
England.
Huh. Okay.
London
London. Got it.
is the number one name.
Very cool.
Nice statistics.
So if the absolute value was lower than the critical value, no correlation, and we wouldn't have to answer all of the other questions?
Two questions. First one, if absolute value wasn't bigger than it, then we would say no, there's no linear relationship. And I beat that by saying regardless of whether a linear relationship exists or not. Do it anyway. Excellent question. What's your name? Alondra. Kelsey. Alondra. All right. There was another question over here. All right. Excellent questions, guys. This is how you slow me down. You ask questions so that I know you're not with me. If you don't say anything, I think you're good, and then I keep going. So, when I need to slow down, you ask me questions so we can stop and review and cover anything that you're missing, anything that I did too fast. What else you got?
Can you go over the strength and the direction again?
Absolutely. So, direction, let's go back to this. So we're only talking about linear relationships. So for our lines in college algebra, we said the slope was either positive, our slope was negative, our slope was 0, or our slope was undefined. So it's kind of like that same concept here. So when we looked at our scatter plot, our graph is going down and to the right. So if we tried to draw a line through that, the slope would be negative. So that's why we said the direction is negative, because our points are going down and to the right. And then for our strength, our R value can only be from -1 to +1. So -1 and +1 means it's perfect. Every single point that we have lies on a line exactly. So if you get anything close to -1 or +1, we say that's a pretty strong relationship. It's pretty fairly well defined by a line. Anything that's close to 0 then that's when we say it's a weak relationship, because your points are scattered all over the place, and you can't really get a good line to determine that. Yes?
You said you only get 600, yeah, that was the last question.
Mm-hmm.
Are usually a different number?
Okay, let's see.
Can we go back to chapter 3?
Wednesday, absolutely. Other questions? Yes.
What point is it considered weak? Is it like 0.5 and below? Is it considered weak, or is it?
That is an excellent question. It's subjective.
Okay.
So pretty much what they say is anything from about 0.7 to 1 or negative 0.7 to 1, we call that fairly. Sorry, I'm getting distracted. Just people outside the windows and hoods and stuff. Make you nervous. Y'all know. Yeah, so 0.8 to 1 or negative 0.8 to negative 1, we call that fairly strong. And then from like 0.8 to maybe 0.6, 0.55, something like that, we call that relatively strong or moderately strong. And then from like 0.5 to 0.2, we call that weak. And then anything from like 0.2 to 0, we say none. But it's hand wavy. Excellent question. Yes.
What was this question again?
How do you know when it is relatively strong? Like when you say strong, when you say weak? And so the answer is, who knows? It's hand wavy, meaning kind of value sometimes around these numbers. But yeah.
But it's between -1 and +1.
Yeah, it's gonna be between -1 and +1, but we say pretty much 0.8 up or -0.8 down. We say that's strong, a strong positive or strong negative. If it's anywhere from like 0.3 to 0 or -0.3 to 0, we say that doesn't exist. And then if it's like 0.3 to maybe like 0.5, something like that, we say is weak. But all of that's hand wavy. So the questions that I'll ask you, it'll be pretty obvious that it's either strong or it's weak.
But generally it's strong.
Strong or weak. You normally won't have anything that's moderate. Yeah, so nothing in between. They'll be on the extremes, one or the other. Very strong or very weak. All right, 4.3, coefficient of determination. We have R squared. Capital R, same exact thing as lowercase r. Capital R squared, same exact thing as lowercase r squared. Different technology, you have different people creating the software, so they're using different letters, but they all mean the same exact thing. So, R squared is our linear correlation coefficient squared. The other one is R. If you square it, you get R squared, and that should get the coefficient of determination. This value is between 0 to 1. That should make sense. R is between -1 to +1. If you square that, you square any negative number, it becomes, yes, exactly. So that's why this one is between 0 and 1. if r squared is equal to 0, the least squares regression line has no explanatory value. Your equation is crap. It doesn't do anything for you. If r squared is equal to 1, then your line explains 100% of the variation. It can predict exactly what's going to happen. In real life, you never end up in that situation. The closer your r squared is to 1, the better the line is. So, let's look at 3 examples. Data set A is what you would ideally want but never happens in real life. You do a scatter plot, you draw your best fit line, your least squares regression line, and that line hits almost every single point. And our r squared value is 99.9%. The way we interpret this is we say 99.9% of the variability in y, you tell what the y value is explained by your least squares regression line. If we look at data set B, our points are more spread out. Yeah, it lands on one of them, but for the most part, it's a little bit different. So this r squared value is 94.7%. 94.7% of the variability in y, the interest rate, is explained by this line. Still very good. Data set C, our scatter plot is all over the place. So when we try to draw a best fit line between it, our r squared value is 9.4%. That is one of a poor model. That's not going to do much for you. So, same example we were working with. Credit scores. Our r squared value is also given on that same screen for regression. It gives us all the information we talked about today. So A is our slope, B is our y-intercept, r squared is our coefficient of determination, r is our linear correlation coefficient.
And you said the lowercase r and the capital R are the same.
Absolutely right. Interpret our coefficient of determination and comment on the adequacy of the linear model. How good is this model?
Fairly
That's
good.
fine.
Fairly good.
Fairly good. If you understand why somebody does something 95.2% of the time, then that's pretty good. Sometimes you're going to be wrong, but 95.2% of the time is pretty good. And here is our interpretation, just like it says in the table above. We're going to take y out and actually tell what y is. 95.2% of the variation in interest rate is explained by the model, is explained by the least squares regression line. So 2 problems that I skipped that we need to go back and do. And then we're going to go through your project number 2 again.
How do you get to R, like find R on the calculator?
Stat, calculate, and then option number 4, linear regression.
Mine's giving me an error.
Alright, one of the 2 problems we skipped is right above that one. We are given 4 diagrams, and we have to match it up with the corresponding r squared. R squared is between 0 and 1. One means there is 100% of your information is explained by the model. Your points are gonna lie directly on that line. So C matches up to which graph?
Full.
There you go. Then you want to go with the next easiest one. Where are all your points all over the place? That should be the smallest R value. So D matches up to, there you go. And then we have two options left. One with the R squared value of 58%. The other one with the R squared value of 90%. The difference between the two, which of those graphs does your points fit the line better? They're closer to your line. There you go. So 2 should be for B and 3 should be for A. So start off with the easy graphs first, the ones that are very obvious. One where your point is close, your points are closest to the graph, the line. The other one where your points are furthest away from the line. Once you have identified the easiest ones, then you go back and do process of elimination. Out of the 2 graphs you have left, which graph are the points closer to your line? That should have the highest R value. Everybody with me?
Yes.
All right, the other part I skipped, problem number 21. Here we have some real world situations and we need to think about them and tell whether we have a positive correlation as one number gets bigger, the other number is going to get bigger as well. A negative correlation as one number gets bigger, the other number is going to get smaller, or no correlation and support your opinion. So A, the number of children in the household under the age of 3 and the expenditures on diapers. Positive, negative, none. Positive, there you go. More kids, more diapers. Interest rates on car loans and number of cars sold.
Positive.
Negative. As your interest rate goes up, the number of cars you're going to sell goes down. And C, number of hours per week on a treadmill and cholesterol level.
Negative.
Negative. One of those three. So, you might work out a long time on a treadmill because your diet is horrible and you have high cholesterol. You may have genetic factors that say you have high cholesterol, so it doesn't matter how long you spend on the treadmill. It all depends on your supporting your opinion. If you would have said people who spend more time on a treadmill are most likely healthier, they most likely have a better diet, so most likely they have lower cholesterol levels, then that would be negative, and that would be perfectly fine with your explanation. So, it could be negative if you thought deeper into the question and you said that people who spend a longer time on a treadmill are probably healthier, so they probably have a better diet, so they probably have a lower credit score. Cholesterol score.
I think she was asking about
I was asking for
A B.
Oh, I'm sorry.
interest rate on a car loan.
Gotcha. All right, so we got your interest rate. And then you have number of cars sold. If your interest rate is 0%, meaning that you're just paying whatever the sticker price says, you're gonna have a lot of cars sold. If your interest rate jumps up to say 30%, people are not gonna buy that same car if they know they have to pay 30% more to you, to the bank. So you're gonna have less sales in that case. So then that's why we say that is negative. So as interest rate goes up, number of cars being sold is gonna go down. All right, pull up project number 2.
breakdown of the 2013 master's curriculum.
All right, every group should have their data set picked out and your variable selected. Part A, mean, median, mode, range. Where are you going to go to find the formula for mid-range? This is not in your textbook. Thank you very much. These data come from a sample, so make sure this is your sample variance and your sample standard deviation. We want everything rounded to the nearest hundredth. How many decimal places should that be? 2. Q1, Q3, your min and your max. Is your data skewed left, symmetric, or skewed right? Explain how you decided. I compared the mean and the median and found blah, 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 so my data is blah. I created a stem and leaf plot and found that blah, 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 so I picked blah. I used the histogram, I used the box and whisker plot. You tell what method you use, and then what about that method tells you whether it should be skewed left, symmetric, or skewed right. Should the empirical rule or Chebyshev's inequality be used on your data? Explain why. My data is symmetric, so I have to use empirical rule. Sorry. My data is bell-shaped, so I have to use empirical rule. And bell-shaped does not mean symmetric. Symmetric can be this. That's symmetric, but that's not bell-shaped. Symmetric can be this. That's symmetric, but it's not bell-shaped. So, empirical rule is only if your data is bell-shaped. Chebyshev's inequality works anytime. 2, calculate by hand the percentage of observations that lie within 2 standard deviations of the mean. You found your mean in part A. You find your standard deviation in part 7. You take your mean and you subtract 2 standard deviations. Oh, that is cute. 2 standard deviations from it. You take your mean, you add 2 standard deviations to it. You see how many of your data values fall between these 2 numbers. Divide by your sample size, and then multiply by 100 to change it to a percentage. E, using empirical rule or Chebyshev's inequality, what percentage of your data should be within 2 standard deviations of the mean? If you said your data was bell-shaped, empirical rule says you should see how much of your data. 95%, thank you very much. If you said your distribution was anything else other than bell-shaped, Chebyshev's inequality says you should see at least 75. At least, you have to write at least 75%. Pick one observation, find its z-score. Go to your data set, you pick a number, calculate the z-score of that number. Pick one observation, find its percentile, go to your data set, pick out a number, count how many of your data values in that set are that number or less, divide by your sample size, multiply by 100%. Calculate the IQR and give its interpretation. For your data, which measure should be reported in summaries? If your data is symmetric, we report the. If our data is skewed, we report the. For your data, what measures should be reported in summaries? If you said your data was symmetric, you report the. Thank you very much. If you said your data was skewed, you report the. All right, calculate the lower and upper fences. My lower fence is this. My upper fence is this. Do you have any outliers in your data? Yes or no? If it's yes, what are those outliers? You create your graphs in part L. Make sure to include titles on your graphs and axis titles. You need a stem and leaf plot. That is only going to have a title. You don't have axes on a stem and leaf plot. Histogram, you do need all 3. pie chart, you just need a title because it does not have an axis to have an axis title with. Box and whisker plots, only a title and a horizontal axis. Frequency distribution, relative frequency distribution. You can build these in Microsoft Word. You go to insert, you click on table, there's your table. You have whatever that's supposed to be, and then frequency over here, or relative frequency, and then you write it all in and go. And the dot plots. Then the part that we covered today is the very last part. Everybody, regardless of what data set you use for the first parts, everybody, every group is using 2013 SAT results by district for this part. You're using the critical reading mean for your X. You're using the math mean for your Y. We want to create a scatter diagram of your data. We want to calculate the linear correlation coefficient. What letter corresponds to that? All right, when you review your notes, you'll see. Determine whether a linear relationship exists and explain why it does or does not. So, in our book, this is your chart. Our chart only goes up to 20. But in that data set, there are way more than 20 observations. But what you should notice is as you go down this chart, the value that you have to beat is smaller and smaller and smaller and smaller. And this data set, it is very obvious. Hint, hint. Very obvious. If you're still confused, there's a great website called Google that you can Google critical values of the correlation coefficient, and it says at 90 you have to beat 0.207. At 100 you have to beat 0.196. Then, regardless of whether a linear relationship exists or not, give the equation of the least squares regression line. Using the first observation in the data set, calculate the residual. Yes, we're going to go through how you find that. Interpret the slope, interpret the y-intercept, calculate the coefficient of determination, and interpret it. Your project is now done. You can do everything. And when do you have to turn it into me?
On the March 2nd or 3rd?
Yeah, March. So you have lots of time to get it right. As always, grade sheet at the bottom. You write your group number, your name, grade your group members on a scale of 0 to 100. What did they do well? What can they improve on? If you don't submit one, that means everybody gets a grade of 100% from you. And at the bottom, it calculates that your group gets a grade. Whatever your team members grade you, you get that corresponding percentage of the group grade. So, if you do everything you're supposed to do, everybody gives you 100, you get 100% of the group grade. If you were late to meetings, you didn't answer emails, you only did half of the project when y'all met, you only came to 1 out of 2 of your meetings, your attitude was stank, any of those, then your percentages can be less, and you can have a score less than what the group earns, which is possible. So just do better next time. That's all. Any other questions about project number 2? All right, let's go to my stat lab. And once you're in my stat lab, let's go to StatCrunch. My stat lab, StatCrunch, we're doing problems from the textbook, so you want that first link, data sets from your textbook. And the problem we're doing is from chapter 4, section 1, problem number 26, the one with credit score and interest rates.
Nice.
Chapter 4, section 1, problem number 26. So my stat lab, click on StatCrunch, data sets from your textbook, chapter 4, section 1, problem number 26. So for your project, you need a scatter plot. So we're going to go to graph. We're going to go to scatter plot. Our X variable was our credit score. Our Y variable was our interest rate. We can scroll down to the bottom. Our X-axis label, credit score. This is how you put your labels in there. Your Y-axis label is your interest rate. Our title, whatever you want your title to be. Once you are done, what do you need to press? Compute. Thank you very much. There is your scatter plot. To get it into Microsoft Word to submit, under options in your top left-hand corner, you can save, you can copy, you can download. That's how you get it into Microsoft Word so that you can turn it in. Everybody with me?
Yes.
Absolutely. Which part? All over again?
Graph and scatter plot.
Yep. So we went to graph, scatter plot, X variable, credit score, Y variable, interest rate. We scroll down to the bottom and we put our X-axis label, Y-axis label, and title, and then compute. Don't you love technology? All right. Then we want our actual calculations. We press stats. Under stats, we go to regression. And in introductory stats, all we care about is simple linear. At the very beginning, we said there are other types of equations that you learned in college algebra. And once you take another statistics class, hint, then you can talk about other types of regression. All we care about right now is simple linear regression. So stat, regression, simple linear, X variable, credit score, Y variable, interest rate. Scroll down. Under save is where you find residuals. Scroll down. Under save is where you find the residuals. Part of your project is calculate the residual of the first observation. Let you under save is where you find residuals. And when you read the section like you were supposed to before you came to class, you should have read what the formula for residuals is. You're like, oh, okay, that's correct. All right. And you can get your scatter plot from here as well. That's what the graph properties are about. So you could just do this one step to create your scatter plot instead of doing them separately. Once you're done, you press compute. And what you should see at the top, you have one of two. First screen gives you your output. Second screen is where you're going to get your scatter plot. So it tells you your dependent variable, your Y variable, your result, your response. That is your interest rate. It gives you your independent variable, your X variable, your factor. Then it gives you your equation based upon those variables. So your interest rate, that's our Y hat, is equal to 61.369, that's our Y-intercept, minus our slope times our credit score, the X. Here's our sample size. Here is our correlation coefficient, R squared. If you want to see it in another way, we have our chart, intercept listed individually, slope listed individually. When we get to chapter 10, we're going to talk about what is a p-value, so you'll know how to interpret this. If you want to see the scatter plot, you just click the arrow at the very bottom to go to the next screen. And there's your scatter plot with your least squares regression line superimposed on it. So both of these graphs are perfectly correct. Make sure you change your title and your axis titles on them. To get your residuals. A new column was now added, and there is the residual for your first observation. Questions, questions, questions. I'm telling you. Questions, any questions? All right, 5 more minutes. Let's do homework problem number 18. So everybody's numbers are different, but the concept is still the same and the questions are going to be same. Number 18. Number 18, that's the one you want. So, suppose a professor records the number of days absent and the final exam scores for students in his class. Use this data in the table below to answer questions A through D. So, in our calculator, where do we need to go to enter these values? Stat, excellent. And then after stat, where do we go? Edit, excellent. And if I have data in here that I want to get rid of, what do we need to do?
Clear.
I gotta press clear, but where do I gotta go first? Before I
Oh,
press clear?
oh, up. Here we go.
Excellent, excellent. And we can do that twice. Your X variable should always go in L1. Our Y variable should always go in L2. Make sure once you type everything in to go back over. This is very easy to miss a number, to miss a decimal place. And you're entering in your values on your homework, so you already have it. All right, part A, find the least squares regression line, treating the number of absences as the explanatory variable, the X, and the final exam score as your Y. We need 2 decimal places, so where are we gonna go to get this slope and y-intercept? Calculate, what do we go to before calculate? Stat, there we go. Then calculate, and then, there you go, number 4, linear regression, enter. 2 decimal places. Fantastic, nice job, excellent work. B, interpret the slope and intercept if appropriate. Our slope by definition, every time we increase X by 1, the Y is going to increase by or decrease by that slope on average. Our X is the number of absences, so every time we increase the number of absences by 1, then the Y, which is the final exam score, is going to increase or decrease by our slope on average. So we have to interpret that based on what they are giving us. One option, E, is never appropriate for me. You can always interpret a slope. You can always interpret a slope. So that's not it. Your slope is not the average number of absences because average is a mean. Your slope is not the average final exam score because that is a mean. So we're down to 2 possible options. And the option you want is the slope indicates the average change in final exam score for an additional absence. Every time your X increases by 1, then the Y variable, our final exam score, is going to increase or decrease by the slope on average. Everybody with me? And it's time to go. Goodbye.